Sweet. Okay, hello everyone, and welcome. This is my talk today on Git and GitHub. It's going to be a combination of two different talks, basically. The first one is a bit more of an introduction to Git and how you work with the command line. And then we're going to talk through some enterprise type stuff with GitHub, talk about the new features that they've been implementing, and then we're going to dig in and go through an example of how we might use those. So let's start with who am I? I'm a full stack software developer here at the U. I work with Alex, who's sat here in the audience. Here I develop a bunch of applications. I've got some examples to show you in a second here. And then I help tutor our PhD students. So that involves helping them build their applications, checking their code, making sure that things are maintainable into the future. And I mostly work on web-based stuff. So lots of JavaScript and SQL and some backend stuff with Python. Before this, I worked as a full stack data scientist at Imperitas. So Imperitas is a small marketing startup. And while there, I would build machine learning models for banks, customer lifetime value analysis, which tells you how much money a customer might spend with a company over a certain amount of time. And we implemented them for companies across Utah and the entire US. So here's a plug for some projects that I've worked on. So the top one here is Sanguine. This is a data visualization tool to help visualize patient blood management data. So this tells doctors if they're over-transfusing, under-transfusing, and maybe how they might make an adjustment to have better clinical practices. The second one here on the right is Multinet. This is the project that I've worked most on in my last 3 years here at the U. It's for visualizing multivariate network data. So a multivariate network is a network that might have attributes. For example, a social media network where you have ages of people, maybe their country of origin, and maybe you have attributes on the edges too, like this person liked this person's post 20 times. So 20 would be like an attribute on edge. And then finally, I worked on AQ&U. This is a air quality in Utah visualization. And this is just a simple web app with a backend that lets us see all the air quality monitors around Utah. So today, like I said, I'm going to be talking about two things. Do a basic introduction to Git. So this is how to use Git on the command line. Should be like just a small piece of this talk. I'm expecting that most people know how Git works, but I'm going to go over the commands here. And then we'll talk about merge conflicts and how to resolve them and how PRs might help us with that. PRs being pull requests. And then we'll talk about how to leverage GitHub. So we're going to look at the features of GitHub. 3 specifically, and then we're looking at how we might use these tools to fix a problem. So to start, this is a basic Git workflow. On the left here, I have the main commands that you would use as you're working on a repository. So you might add to stage your changes. You might commit to then push those or to move those stage changes into permanent commits in the repo. And then you'll use git push and pull to interact with a remote like GitHub or GitLab or something like that. And this kind of gives you an idea of how it works over here. So you end up, your local working directory will have some changes in it. You'll use git add to move it to this staging part in the middle here. And then you'll use git commit to solidify those changes in your local repository. And then you'll push, which is this one down here, and that will go then to GitHub. You can then also git pull to make changes to your working directory from GitHub. So if someone else has changed some code or you're out of date, you can pull it back from GitHub. And then there's also the stash and apply at the bottom here, which is for temporary changes that you want to put away for a little bit and then pull them back out. In terms of more advanced commands, there are merges, rebases, and checkouts. So a merge is when you have 2 separate branches that you've been working on. And you want to combine them into one branch, you will merge the branches together and the commits will be linearly arranged. So this is, for example, if one person's worked on a feature, another person's worked on a feature, you want to combine them together onto your main branch, and you do that through merging. There's another strategy though, we can use rebasing. And you'll see here, these are the 2 different ways. So if we merge, we end up with all of the commits here in the tree, and this red commit is the end here, so everything above it is in the tree, basically. You can get to it with arrows. Whereas when you rebase, it's like, imagine you making commits and then you branch off. To rebase is to move the branch up the tree. So you move it onto a different base, you rebase it. And that's a different way to handle the like changes being out of order, essentially. Like you want to move them so that they're in order on the end of the branch. Checkout, which has now become two commands, switch and restore. Switch is for moving to a different branch, and then restore is for restoring any changes you made back to the original state of the repo. So let's talk about what this might look like if you're just working by yourself. So here, this is my trees. So we just have an initial commit here. The white circles are commits. And there's two parties in this. The first party is the local party, which is you. And then the origin party is GitHub. So as you're working, you might make some changes. You'll do a git add and a git commit. You write a lovely message like add feature 1. And then maybe you do some additional work and then you do an add and a commit, add feature 2. And then here you would push to GitHub and everything's fine. GitHub is up to date. You can see your changes online. And anybody else could review the work that you've done at this point. So when we have two people, this is going to get a little messy. And the more people there are, the messier it gets. So in this case, there are three parties. There's the local and the origin, which again is you and GitHub. And then you also have a collaborator here that you're working with. So maybe you make some changes and you do add feature 1 again. And then your collaborator at the exact same time is working on the exact same code to add a different feature. You're lucky, you beat them to the punch and you push. And then the collaborator tries to push. At this point, they're going to get an error if you've been working on the same code. And it's going to look like this in the terminal. It's going to say rejected, main to main, can't fast forward, failed to push some refs. So that means you can't push those commits up that you wanted to push. The way to resolve this, it will tell you in the command line, is to pull. So your collaborator would pull. And this is where they might encounter a merge conflict. The merge conflict essentially says you both changed this file in the same place, and I can't resolve how we might reconcile the changes. There's no way to easily fix it. For example, maybe your collaborator deleted a file and you modified that file. There's a kind of undefined behavior in how you might go about merging that. Maybe the file should be deleted, period, or maybe it should just be slimmed down and you just need your change or something like that. So what would happen here is your collaborator would figure out what needed to happen, fix it up, and then they would say git commit and git push. And now GitHub will be up to date. And then you can pull just fine. And you won't have any conflicts because the conflicts have been resolved already by your collaborator. So you can see here that this is an okay way of working. But it could be much better maybe. So the pros of this approach are that it's simple and fast if you're working by yourself. But the cons are that you're going to end up with merge conflicts. It's hard to resolve those merge conflicts sometimes. There are no reviews or feedback. So the code that you've submitted hasn't ever been looked at by anybody else. You've just pushed it up and they're going to take that code regardless of what's there, which if it's broken code is not going to be good. And then potentially say you were working at the same time as somebody else, you commit up half of your feature and you push, the other person pushes up half the feature, then you finish your feature, push, they finish their feature. You're going to have all out of sync commits, which could be problematic if you're trying to go and find where something broke in the feature that you engineered. So how can we make this better? The answer is with branches and pull requests. So let's talk about what they are and how we can collaborate using pull requests. So what are branches and pull requests? A branch is a space to work on your code undisturbed. So it's a way for you to be able to push to something like GitHub without having somebody else pushing code at the same time and giving you conflicts, essentially. It usually represents a logical unit of work. So maybe it's a new feature, maybe it's a bug fix, something that encapsulates one chunk of work. And it's a way to keep the main branch clean and deployable. So quite often when we do our work, our main branch is the source of truth. We don't want to disturb it and potentially have any issues. And we're always deploying the main branch. So if there's an issue on main, it's an issue for the people using our application too. So by working on a branch, we can mitigate that risk by making sure that all code is reviewed and is working by the time it gets there. So there's a couple things we have to know about Git and GitHub. So when we're pushing, we're essentially trying to force code into the branch. So we're saying, you don't have this code. I'm saying this code is good. You should take this code. That is fine and it works for some occasions. But in general, we want to ask for permission, especially if we're working on somebody else's project or collaboratively. So that's what we do with our PR. We're basically asking for permission. And we'll see what that looks like shortly. It also allows us time to run automated tests or even manual testing, linting, and it helps us highlight things that might be broken and in need of fixing before we continue and push the branch into main. That said, not all PRs are good PRs. We'll go through some examples of some ones that I've written that I think are okay. So hopefully they're good. But quite often it can be burdensome to collaborate over pull requests, especially if you're not both on the same page, you and your collaborators are not on the same page. So the way that we mitigate that is we use great descriptions and good messages for our commits. And we try and tell a story as we're making our commits so that somebody could follow along logically and see, oh, this person fixed this for this reason. And you know, it kind of makes logical sense to them. Okay, so here I have a link to a simple example. So here is a pull request that I've made. The branch that I was working on is called generalized workflows. You can see that right here. And then the description, or sorry, the title that I gave the pull request is use the generalized linting workflow from the organization.github repo. So this is simplifying things on our end. So what this actually means is we're going to run linting, but instead of defining it locally and like having bespoke code for each repository, we're going to use the organization's workflow essentially. So just from the title here, you get a pretty good sense of what might be going on. We can go in and look at the files changed. Here, this is the changes. So this is the removal of the bespoke code, and this is the adding of the organization code here. And then you can see in the commit stream that the messages are logical. It's actually the same as the title here. And then I give a nice description. This is our pull request template that I developed. And it shows, it first asks, did it close any issues? So we'll talk about issues in a little bit, but issues are up here. And if there's a bug or a feature request, we'll use issues to track them. So the first thing is, does it close any of those? So I said, no, it's just an improvement to reduce redundant code across repos. Give a longer description. So I've added an action in the .github repo that handles this logic. The game plan is to use that instead of bespoke code in each one here. If there are any pictures or videos, because I do a lot of UI work, I would include those here. And then I just have a little to-do list here that I worked through. In this case, there was no review, just because it was such a small change. It wasn't worth having anybody look over it. But in general, like we would go through a review at this stage. Any questions about this? Feel free to ask questions at any point as well, and in the chat. Okay, so with that, let's go to a more complex example. This will make sense shortly. Okay, so here's a slightly more complex example. I'm not using our template here. This is from before the templates, but you can see here that I'm mentioning that it's closing an issue. The issue, we can go hover over it and we can see the tooltip location when hovering needs to be fixed essentially from this issue. You can see here that I've called out that I'm changing the logic that sets the location for the tooltip. I'm reordering events that are happening in JavaScript and then adding a z-index. Z-index is just a height on the element. And that's also reflected in our commit stream here. So you can see that this is where I fixed the location, this is where I fixed the event order, and this is where I fixed the z-index. In this one, you can see the files changed. There's a lot of removals, some additions. And this one was reviewed. It was reviewed by my collaborator, Daria. And she said, looks great. I gave a little Tony the Tiger and we merged it in. And we can see as well that in this one, we were running like a build and test here and some automatic deploy previews. And all of this is part of our workflow with GitHub. And the final example that I would like to talk about is this one, which is just a longer commit stream essentially. So the idea here was to add axes to a variable driven layout for this application. A variable driven layout is using a variable to lay out nodes. So in this one, we're using, this is a group variable at the bottom. It might be hard to see. We're laying it out by group. So we can see that there is some nodes in this group, some nodes in this group. And then we can see the connections between groups as the lines. This one has a long commit stream here, like I mentioned. But if we go through and just read a couple of them, you should see that it at least makes logical sense as a story. So I moved variables closer to where they're used. I moved variables around in context menu. I reset layout variables by updating the object, not the properties. Added layout access logic with some extra padding. For example, like if you were looking at this as a reviewer, while this might not make sense to you right now, if you worked on this project, you would understand roughly what I was working on here. This is quite a big pull request. So you can see over here, it gives us a idea of how many lines have changed. In this one, I've added 224 lines and taken out 93 lines for 317 total line changes. That's quite big for a pull request, and I'll talk to you a little bit shortly about how big they should be, but you don't want to overburden your reviewer by having them look at too many lines of code, essentially. Then I added another image here, just to show what it looks like when you're using two of the encodings. And again, we had our building and testing that ran automatically right here. And then this was committed into main. Okay, so the best pull requests are short and they add only one thing. There's a unofficial rule of 100 lines. If it's getting over 100 lines, you should be looking to split up your pull requests so you're not burdening a reviewer. And of course, your commits should be telling a story. At some point, we can share the slides here, and I have a little article, how to make your code reviewer fall in love with you. This is review your own code first, write clear change list, automate the easy stuff, answer questions. This is kind of what I built up these slides from. So you'll have that resource if you're interested in it at the end. There's a couple others here about how to do the opposite one, so how to be a reviewer. You don't want to overburden the person submitting code as well. And then this is for rebasing, which is a bit more of a complicated action in Git if you're interested in that. Okay, are there any questions about Git and its usage and why we might use branches and pull requests before I continue on? Nothing in the room. Yeah. So the question was for people watching online, if you're just coding by yourself, is it worth going through this whole process? Is it worth the effort? And I would say yes. So I actually do on my own website. I make pull requests to myself, write myself little notes. And I find it super useful if I need to go back and fix something, just to see it all in like one logical piece of work that I can go back and click through. So I think that there's definitely a benefit to it. It can be burdensome. I guess it depends on you. I can't sit here and say you must do this, but I think it's useful for sure. Cool. With that, we can continue on with the GitHub enterprise features, and we can talk about how to leverage some of the cool new GitHub technology in our development here. So there are three things that I'm going to talk about related to GitHub. Issues, which we already touched on a little bit. Actions, which are those automated tests that you saw running at the end of my code. And CodeSpaces, which is a way to run your development environment from a virtual machine on GitHub itself. So issues and discussions. Issues are a place to track your bugs and feature requests. So in this one, you might have your boss, people you're collaborating with, your users. They may see something in the app that's broken and say, hey, you should fix this. GitHub issues is a great place for that. It's a place where users can get help. Maybe they're having just a slight problem and don't know the correct thing to run or something like that. And you can help them as a developer. And it can be used for project management using the new beta. So they have like a spreadsheet view, which is pretty common to have when you're doing project management. And we'll look at an example of this shortly. There's also discussions. Discussions kind of confused developers, I feel like, when they came out, in that they were sort of like issues, but also not. And they didn't seem to have a clear value add. But I think that they've kind of coalesced their messaging recently. And discussions are intended to be forum-like. So I'm thinking of it a little bit like Stack Overflow, in that it's a place where users can collaborate to find solutions instead of asking developers specifically directly. And it's a way that you can have them discuss the software kind of hands-off. You can also make announcements here for releases, and people might discuss like, oh, this feature worked in this way or didn't work in this way, or unintended consequences or something like that. Although I don't personally use discussions for our projects at the moment. So let's look at an example issue here. This is what our workflow looks like for issues. So one person will make an issue. In this one, variables in multiple tables will cause a clash if they have different types. I gave a little description here. Somebody said, oh, this might be a way to fix this. If we just check the table name and the column name instead of just column name, we might be able to fix it. I commented back that yes, that seems like a reasonable solution, but we still need to code this up. I want to go quickly look at an issue that we're going to be talking about later as well. Come on here. So we'll be working on this issue a little bit together later. So let's just get familiar with it now. So I opened an issue here saying update the node version of the GitHub Actions runner to node LTS. So this is updating the version of software that my website builds on to the LTS version of the website. So sorry, the LTS version of Node. And this is running on GitHub Actions. So this is running on GitHub itself. For example, I've said I'm currently on 16. I'd like to bump to the newest LTS. This is how we might do it. And we should also update to using version 3 of the action. So issues are a nice way to track, again, like a logical piece of work, kind of outline and describe and potentially discuss how you might get to a solution on this. Okay. And then this new version of issues that lets us do spreadsheet tracking here. This is best for project management. So I'm working on a project here where we're going to set up a website using an API, a client. It's going to have some infrastructure that's defined in code. And we want it to track everything that's going on. So here you can see that the default sorting is just what's been closed and what's open alphabetically. But we can change that up. So I'm going to group here by our milestones. And then I'm going to add a couple columns. So I'm going to add on the repository here so we can see what's going on. Okay, so now we can see what was open for August 1st here. So we wanted to do basic user management, set up a development database, have a front end login. These are all still open and need to be completed. But we can see that it's some of this is in the API, the infrastructure front end. And we can get a rough idea of how much work is here to be done. You can see that for July 1st, we finished all of our action items here. And then we have some going out into the future, some tentative deadlines that we are going to be adjusting. But this is a good way for us to manage this project. And we're able to see like where we are relative to our deadlines, basically. This is good if you're working as a group. Everyone can get a good overview of this. And you can even share this publicly. So if you have a bigger project where you have public releases and tons of users, you can basically make this into a roadmap that they can see and see how you're progressing along on it, if that's desired, which is not always. Okay, so the next thing we're going to talk about quickly is GitHub Actions. Actions are a way for us to do CI and CD, which is continuous integration and continuous deployment on GitHub using Microsoft's infrastructure. So CI, continuous integration, is continuous testing and linting. We're looking at our application to see if there are any bugs in the code that have been found by our automated tests, if the code is up to the linting standards. This will all be flagged here. So each time we're going to open a pull request, we expect that that's a small change, like one piece of work. So we can see here that these small changes are tested very frequently. So troubleshooting is faster, and we're not going to add 15 features and then figure out which one broke our application. In this case, we can just figure it out from the pull request. And then authors and reviewers can both immediately identify problems. It's presented to you as like a public thing on GitHub, and you can see, oh, this was the problem with it. I need to go in and fix this specific line. And that's good for both authors and reviewers, because authors can see, oh, this line is what's broken. Maybe I can help you fix it. Or maybe I can go fix it. And the reviewers can say, oh, maybe I can help you go fix it if it's something small that shouldn't hold up a pull request. Continuous deployment. So a principle of continuous deployment is that your main branch for your repo is always your source of truth. For example, the main branch on GitHub would be this at the moment. The idea is that with continuous deployment, no manual intervention is necessary. So you don't have to SSH into a server and click or like type deploy or whatever your script might be. You just push code, and as soon as it's merged, it gets deployed, is the idea. And there are numerous providers and integrations to help you do this through GitHub. GitHub Actions are free for open source, and you get 2,000 minutes even in a closed source repo. Lets you do automated CI, and you can hook into other things to do your CD, continuous deployment. And then the idea of Actions is that you have an event that triggers a workflow, which contains jobs and runs on a runner. So these are the nomenclature of GitHub Actions. But yeah, so basically you have an event that triggers jobs is how you can look at it. It integrates well with other providers for DevOps. So if you're deploying a website, maybe you have a lot of infrastructure you need to take care of, or if you're deploying a desktop app, maybe you need to build it up, bundle it, put it on a website somewhere so your users can download it. This can all be done using Actions. It means all your code stays on GitHub's infrastructure, so you don't need to farm it out to like a third party. There's other companies that do continuous integration, like Circle CI. But using GitHub Actions means it's all just in one place, especially if the code is sensitive. That can be important. And it can run across a matrix of runners and software versions. So say you need to build something for Windows and Mac and Linux, you can do it all at once using this one piece of code. And then finally, we'll talk about CodeSpaces. CodeSpaces are a way to make standardized cloud developer environments. It uses VS Code in the browser or locally, and you connect into the virtual machine. You're able to code on the virtual machine. You're able to run your software on the virtual machine. You can use infrastructure as code to describe the way that you'd like your software to run. And it gives you really crazy fast onboarding for new users. So once you've set it up, anyone that joins your organization can just hop into a virtual machine and can start coding immediately. There's no need to install dependencies on your own machine and mess around with all that. So it can be really quick. So for me as a web developer, the first question that I had was, how does port forwarding work? So that's where you want to connect into, maybe if you're developing locally, you would do localhost 8080, you connect in and it would be serving the website. Like, how does that work if you're going to be working in the code space? Are there any limitations? Can you maybe only run one program at a time? Can you only serve the client when you need the client in the API? How does all that work? We can talk about that now, I suppose. So there is no limitations. It runs using Docker. So you could run your API in Docker, and then your client, you can run either locally on the command line or also through Docker. You can basically have everything running at once. It's just like if you're developing locally. And then for port forwarding, we'll see here in the browser in a second as we go into an example. Okay, so I linked to this issue earlier, and we're actually going to go fix this right now during this talk. So thanks for tagging along while I fix my website. Okay, so the stated goal of this issue was to update a software version for our automated GitHub Actions here. And what we're going to do, since this is defined in code, is we'll spin up a code space. We'll go in, we'll make a branch. We'll code our changes, make a pull request. And then hopefully we'll see the GitHub Actions run. And then we'll get a feel for everything that we've talked about today. So GitHub CodeSpaces is in beta right now. You have to go sign up for it if you want it. And you can pay for it on an organization level. But I signed up for the beta, so I get free access here. So in my code dropdown, I have access to a new tab here called CodeSpaces. And it says here, create CodeSpaces on main, or I can click here configure and create your own code space, but I'll just do the default for now. And this is going to take about 10 or so seconds, and then I'll have a virtual machine running with a VS Code connected to it. In theory. Okay, here we go. So right here, I'm in my code space. I have a terminal down here. I can do everything that you would do on a Linux terminal. By default, sorry, OS release. So I'm going to just type the command here, cat etc os release, just to get the information here. And by default, we can see that it made a, by default, it makes an Ubuntu 2004 instance here. And it comes with some normal developer packages installed. So Ruby, Java, Node for building web apps. So down here, I can just ls. So here's my repo. We can see that this is the same repo that I have open on the side here. So I have my source folder, public folder, node modules, things like that. What I'm going to do is type yarn here. Yarn will install my dependencies. Looks like that's already done. And then if I type yarn serve, that's going to deploy my application. And then you end up with this little pop-up on the right here. It says your application is running on port 8080. Your application running on port 8080 is available. And it gives you open in browser is the action here. And you'll see that it'll direct me to a URL. It's going through all the GitHub authentication here. So it's private by default, only I can see this, which is nice. And you can see here, this is all related to my code space. And then the end of the URL is -8080.githubpreview.dev. And I have my website running here. So this is running from this code space. And to prove that, I can modify something in here. Maybe let's go to my landing page. So after my name, I'm going to say hello. I'm going to save that. And in theory, of course it doesn't work right here. Okay, so after Salt Lake City, Utah, I'll say hello. Maybe it's going to need a refresh. Okay, yeah. So you can see that I added there in the code space is available here on this port. It's open. I'm pretty sure it does hot reload, so I'm not sure why I had to refresh there. But oh yeah, see, I removed it and it's removed now. So I'm not sure what was up. Okay, so with that said, let's go fix this issue. So what I wanted to do was update the node version in the GitHub Actions runner to LTS star and use version 3 of the action. So we can use this that I've typed up here to help us. So I'm going to go to the GitHub action here, which lives in the .github/workflows main.yaml file here. And then I'm going to say on node latest LTS. I'm going to change the version to LTS star. Cache is yarn. I had another suggestion for something I might use here, which is check latest. Is true. And then we wanted to use v3 of the action, which is the setup node action, which you can see here is v2. I'll change that to 3. And now if I save this, and I'm going to open up the panel on the right here, which is my changes. And I can look at my diff editor, so I can see that we changed what I just changed. I'm going to add this. That's the same as doing git add on the command line. And I'm going to make a commit here. So I'm going to say update GitHub action to v3 and use node LTS. I'm going to commit. So it's saying you're trying to commit onto a protected branch here. So I actually haven't shown you one thing. And that is that I'm going to do git switch -c for create a new branch. And I'm going to say update node as my branch name. Now I'm on this new branch. It will let me hit commit here. Now I can say publish branch. So with that branch published, we can now go back to GitHub. I can go to pull requests. It says this branch has had recent changes. I can say compare and make a pull request. This title here is pretty good. So this closes. '61, it looks like. And I'm going to say updated node version for the GitHub action that tests the website. With that, I'll create my pull request. And some automated stuff starts happening here. So the first one here is the Linton build. You can see here that it's testing latest LTS, maybe a little small to see. Let me zoom in. So it says node latest LTS right here. This is the change we just made. And if I click on details, I can see the live logs of it running here. So it's running ESLint. It's running yarn build. Builds just fine. And now it's caching all of the dependencies so that next time it runs, it's even faster. And now if we go back to the pull request and I refresh, we shall see that it passed here on the latest LTS. There's some other configuration I need to do, but it's also building the deploy preview down here as well. So using GitHub Actions and all this automation, I managed to update my test, run the test on the pull request, make a nice pull request with a good description. And if someone was to look at this, they could figure out pretty quickly what I've done. And then run all the automated stuff and get a deploy preview. So this is what will actually be deployed if I click approve. There's no code changes on the website, but it still rebuilds each time. Yeah, and with that, that's how you can work with CodeSpaces to make a new branch, make a pull request, get developers up to speed on CodeSpaces. Yeah, there's a ton of useful applications for this, and we'll be using it going forward for sure to get our PhD students on. Yes, Alex.
What's your estimate and/or kind of like evaluate or judge CodeSpaces a little bit? Is it like, what tasks is good for? Is it good for native web development versus not so great for other tasks, right? Or is it great in a year, or is it something that we should all move to now or soon?
So the question is, what types of tasks is CodeSpaces best at? And should we be planning to move now or in a year? So to answer your question, yeah, I think web development is the obvious one here because you're able to build the website and view it on the port. If you're going to be doing something a bit more complex using, I don't know, C++ or something, it might be harder to see the outputs of that from the code space. Unless it's just something like a library, maybe that would be useful in a code space. If you're going to build like a linear algebra library, maybe that would be good in there if you have good testing and things like that. As far as, is it good enough to use now? I think it is. I've used this a couple times for my website, like the way we have it today. And I've really enjoyed it. And I think that specifically for our group, when we're starting to develop new software where PhD students might be coming and going, it's going to be really good to have this set up so we don't have to deal with all the dependencies and things like that.
What about classroom use? For like this class, for example, that's starting in 2 weeks. Would you recommend this for something like this, or would you rather that people do their own thing?
Yeah, so the question is it going to be suitable for students to use in the classroom? GitHub themselves do actually list that as one of the things you might use it for. So maybe like if you have a Python application and you want all the dependencies to be set up for them, that would be a good use case for it. I think there is like the GitHub education plan too that would let you do it. But I think that there are probably better tools for that right now that require a little bit less overhead. Yeah, like a code pen, or like observable or something like that. Yeah. Any other question? Yeah, the question is it for bigger or small changes? I think honestly it can do either. If I wanted to build a full feature, it wouldn't be a huge burden for me to keep coding in JavaScript and just adding on, change after change after change. But yeah, I think it makes most sense as like you're working on it at like a branch at a time. Like if you're going to do like one set of changes, that'd be good. But if you're going to end up doing a bunch of changes across multiple repos at the same time, maybe that would be something you would do locally. Like if you need to change your API and your client and your layer that goes in between and whatever, like the more complex you get, the easier it would be to run just on your own hardware, I think. Are there any other questions? Maybe from the Zoom room too? Looks like Sterling has asked, should you have one code space per repository? So that's a good question. I don't think there's a limit to the number that you can have. I think, for example, if you're working on a branch and then you want to work on another branch, you could just do that through Git's tools on the same code space, but I think you can actually just spin up a new one. If I go back to the code here in CodeSpaces, you can see that I have a code space that I can click on to rejoin it. So opening that in a new tab, it's going to say connecting to your code space again, and they'll be in the same one. But I can also just click create a new code space here. So ultimately, I think it's a bit on you. Like, what's your workflow? Would you prefer to have a different code space for each branch, or, you know, each branch be a new code space? It could go either way. Because they're disposable virtual machines, it doesn't particularly matter what you end up doing. Jerry? Shake it.
Here we go. We throw this to you. I'll throw it to you first. Well, nice one.
Wow. Okay. Sorry, I can't get over that it's fleshy. Anyway, so just to sort of reiterate this code space thing, you're saying the benefit is you have this virtual machine and then you can work across different like different computers, and that's the point of it. Like you don't have to keep like pulling a branch, etc., and like trying to remember where you left off. Is that the point? Like I'm trying to get what the point is.
So there's a few different points, I think. Maybe throw it back up.
Huh?
Maybe throw it back up here.
Okay.
Star Wars in. So the question was, what is the overall? What are the pros of this? When would you use it? So yeah, like you suggested, I think that using it across machines is a huge benefit. So you can start coding on your desktop and then pull it up on your laptop and you have the exact same development environment. I think that the pros are less in that, although that is a pro. I think the pros are more for the people who are helping with setup for projects. So for me, there we work together. Whenever we have to install something new or a new dependency, we all have to go through that process. Whereas if I could just define it in like a JSON file or some kind of markup language and just say, okay, run this in your code space, that'd be way easier for me to manage. And I could know that it's going to work the same way every time. I'm not gonna have to worry about Mac dependencies and Linux dependencies because it's just gonna be running on the Linux VM that we give you, right? I think that that's the benefit, especially across like bigger teams as you have people coming and going. Yeah, it's just gonna reduce the overhead for that a lot. Yeah. So the question is it language independent or dependent? I think it's independent and it comes with a bunch of stuff. So by default, they give you Node, Ruby, Java, and Python, and a bunch of other stuff too. And because it's Ubuntu, you can install whatever you want. So as long as you have a workflow or something that could work with CodeSpaces, like I said, like a library that has automated testing or a website where you can look at the ports, then it would be useful regardless of the language, I think, yeah. As long as it works on Ubuntu. And I think you can maybe even specify that you want Windows or something too. But yeah. I'm just going to look up here. Yeah, other benefits are that you can use a bigger machine than your laptop. So you have like a 2-core laptop that you're working on, you can actually code in a 32-core server somewhere. That'd be really nice. These standardized development environments, like I mentioned, you can just give them out to anybody and they're all the same. And you can do, yeah, this browser port forwarding stuff that they've figured out. Yeah, I don't see specifically here which languages they support, but I'm pretty sure that they give you a bunch out of the box, and because it's Ubuntu, you can figure out other stuff too. Cool. Any more questions from the room or the Zoom? Seems like not yet, but if there are any that trickle in over the next few minutes, I'll be around. But yeah, otherwise, thank you all for coming. Appreciate it.